what is the data, what is the big data, why we need the Hadoop, why not the other databases connections. We'll see everything now. So first, let's start with so what is the meaning of the data? Data is nothing but it's a gathering the information, right? So gathering the information here. So how we can store the data? In terms of the bytes, right? Bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, and zettabyte and yottabyte. See, the future is about bronobyte, right? So if you go with the bytes, kilobyte, megabyte, gigabytes, it's just normal data, right? Even our laptops can handle this data, right? And this one, zettabyte, yottabyte, and yottabyte. And see this one, this is a large volume of the big data, large volume of the data here, right? It's a vast amount, large volume. You know, everybody call it is a big data, but it is simply a large volume. So let's see now. So what is the meaning of the big data? Right? Everybody call it as a big data, but just large volume only. So now, so everybody think like big data is like a software or tool like that. Big data is just simply a term which defines about the three factors here. So one is the velocity of the data, one is the volume of a data, and one is the variety of the data here. So what is the velocity? Like the speed of the data, right, you're getting from the source to the destination. For example, let's see, right now I'm in Hyderabad, flying to the Bangalore, right? See, each and every second, all the flight information we capture and we can analyze. And then we can say, okay, this is about the speed of the flight and this is about the height of the flight. For example, see in a hospital, right? When we scan the body activities, then we can say, so what is the right effect, what is the tableau in the body? So how if the speed is good, right, then we can easy to say decisions, right? So the speed of the information, like if the speed is good, if the velocity is good, then we can make a decision is very fast. Coming to the volume, in a big data, volume is nothing but this large volume only. So this large volume is one of the factor in the big data. So coming to the varieties, we have three types of varieties. One is structured data, one is the unstructured data, and one is the semi-structured data. So what is structure? Like the data, the format is like a tabular format, right? What is the unstructured? For example, see in a Facebook, right? We upload the videos, images, and comments, right? This all comes under the unstructured data. What is semi-structured? Let's see the XML data, JSON data, and the clickstream data. So guys, any idea about this clickstream data? Clickstream is nothing but, for example, let's see, I'm the customer here, right? I'm doing the online shopping with Amazon, right? So, right, suppose I'm doing the online with Amazon. So I enter the website, I want to buy something, but I didn't see any offers, so I log out. You know, after you open sometime browser, right, you will see some ads, right? So automatically you will see some ads in your browser. So how you got the ads? Whatever you do the mouse clicks on the before, right, they captured all of your data and then they analyzed and then they show you some offers to you to attract the customers. So whatever you do the mouse clicks is everything storing on the clickstream data on a semi-structured manner, right? So this is called the semi-structured data. So these three are different types of varieties and these three are different factors of the big data: velocity, volume, and variety. Right. So now let's come into the. So these are all the big data factors we have. Right. So the combination, the whole combination is called the big data. Right. The velocity, volume, and variety. So if you see, guys, around the 4 to 5 years back, we don't have anything on the big data, right? From the past 2 to 3 years onwards, we are continuously hearing the big data word, because of the data is growing a lot continuously. As per the IDC analysis, until 2007, we used around 0.9 terabytes here. Until 2011, we used around the 1.9 terabyte. And in 2012, we got 2.9 terabyte here. So if you see here, around the 4 years of the time, we just used only 1 terabyte. If you see here, from the only 1 year, we got the 1 terabyte. So what I am saying is, like the data, so the flow of the graph is going continuously, like double from the every year here. So let's see here. So first let's start with the here. Let's see the state of the data. 90% of the world data created in last 2 years. See the data here. So all these varieties. So until now we discussed about the big data characteristics. One is the volume, large volume, and varieties. Let's see the varieties here. Text, images, audio, video, numerical, and social media, multi-dimensional arrays, and streaming data, different ways of data we getting. And the speed, let's see the speed of the data. So that's called the 3 V's rule in the big data: volume, velocity, and the variety. Right, that's called 3 V's rule in the big data we have. So, and we have one more V is called the veracity. It means is the data is useful or not. Right. So I got the big data, but as per the client requirements, it is the best or not. It's called velocity. So it means that, so big data is nothing but just simply a term which defines about the high speed of the data, huge volume of a data, getting the so many varieties. A combination is called as a big data framework, big data we have. So let's see now, guys, who is generating the more big data. Social media, right, is one of the best example of the big data. So getting from the different ways, like a Facebook, Twitter, like a YouTube, Flickr, right, on different ways we got the vast amount here continuously. And let's see the scientific instruments. See the NASA, they'll produce weather reports continuously, right? Every second they'll produce the weather reports here. Mobile devices, we are sending the 11 millions of messages through mobile in a 1 minute throughout the world, right? So what I'm saying is here, right, everybody, like all of us are generating here, all of us are consuming here, right? See in olden days, right? So we have newspapers to read the news, but nowadays we have so many online blogs to read the same information. So everybody is consuming here and everybody is generating here. So here the main challenge is how to handle the big data. That is our main challenge. How to handle the big data. So how to handle? First of all, let's see who is generating the more big data and what are the ways we are getting the different types of data we have. See, from the mainframes, client server, internet, mobile devices, social media, and the cloud computing, getting the vast amount here. Every minute we got 98k tweets, 6 lakhs updates in a Facebook, 11 millions of messages through mobile, right? See, this is called as a vast amount. Here you'll get continuously. If you see here, you'll get the very speed, you'll get the very huge volume, you'll get the so many varieties. This is called as a big data. So here the main challenge is how to handle, because guys, here we can't control, right? For example, I'll say, so please stop using your Facebook and mobile. Nobody will stop it, right? No one will stop. So we don't know how to control this big data, so we have to know about how to handle the big data. So what is the meaning of handle? Means how to store this vast amount of the data and how we can process all these varieties of the data. That is my job in the big data. That's my job in the big data here. I want to store the vast amount. Vast amount means start from the terabytes plus. Varieties means I want to process structure, unstructured, semi-structure. Right? So I am looking for a good solution to handle the big data. Right? So first let's go with SQL. So guys, what is SQL? It is a structured query language, right? See, the name only defined, you can access only for the structured data. And the SQL, if you see here, SQL can handle only in terms of the bytes, kilobytes, megabytes, until gigabytes only. But see guys, what is my job in a big data? In a big data, my job is, I want to store the vast amount, I want to process about all these varieties. Right? But using a SQL, as we have limitations, right? SQL has limitations because SQL can handle only for the a small amount of the data and only for the single variety structure only, right? So like this, all the RDBMS systems fail to touch the big data, like Oracle, DB2, all these databases, right? All these languages, they fail to touch the big data. So now, so how to handle the big data? That is my requirement now, right? So let's go with the Hadoop. Hadoop is nothing but it is a data management framework. It's a big framework we have. So what is the meaning of framework? Means we have so many components available, right? We have so many components available here doing on different job. Some will be store the data, some be processing a data, some be import and export, or like this. All of the different softwares on the single framework. We have. See, the Hadoop is a data management. So in a Hadoop is data management here is nothing but in a Hadoop we can store the data and we can store any amount of the data. So Hadoop can access any amount of the data you can store and we can process any variety of the data here. So now I got it right. See, in a big data, what is my job? I want to store the large volume and all these varieties. Yes, using a Hadoop, I can store any amount and I can process any variety here. First of all, let's see, so what is the history of the Hadoop? So how we got the idea about Hadoop technology? First from the Google, right, we got there is one paper for to handle the big data. So for to handle file system, there is one paper here. So based on this paper, Doc Cutting, he got an idea about the Hadoop technology. On the time he is working on Yahoo team, he came with the Apache support. First he released the Apache Hadoop. Apache Hadoop is it's a main origin one, right? And it's an open source. Open source means free software, right? It means I can take this Apache Hadoop, I can customize, I can put my name, right? The same way we got so many flavors of this Apache Hadoop. One of the flavors is called the Cloudera, and one is the Hortonworks, and one is the Mapper. Like we have different flavors. Coming to the Cloudera, right? We got so many advanced tools in this Cloudera, advanced components we have. So Cloudera team, they taken all these Apache Hadoop, they install new components, and then they install the Cloudera manager, and then they gave you as a pre-configured version. Means everything is ready, just simply open and play with that. So this is one of the best flavor we have. and these are all like same like Apache, and all the it's like a all the they make everything of single frameworks. So these all see all the flavors has the same information, but in a Cloudera we got some new tools here, and depends upon the support, right? So I will select the tools here, these framework components. So first let's see the coming to the why Hadoop and what are the benefits, right? So what are the benefits here? For example, let's go with the SQL or Oracle or Teradata or SAP HANA, Google file system, some examples. First let's see in the Hadoop, guys. I will explain that now, the 5 characteristics here. This will say Hadoop is the best solution to handle the big data. So first one is the scalability we have. Second one is the cost effective we have. And the third one is the flexibility we have. And we have a fault tolerance. And next, last one, high performance we have. Okay, so let's see now first scalability. So see in a Hadoop, right? So we are doing the parallel processing here. So it means first, for example, let's see what is the parallel processing. For example, let's see from the client here, I got the 100 terabytes of a data, so taking as a one system, 50 MB speed per second. You know, it will take how much time? How much it will take for processing a data for this data? It will take around the 23 days for processing a data. For example, from the client, I'm taking as the same data, right? Taking as a 1,000 systems, same speed. It will take the half an hour time to finish our job. So what I'm doing here, I have a more data, so I'm taking the more system, so then I can distribute across the more systems and all works parallelly, right? That's called parallel processing, right? In a Hadoop, every component work with the parallel processing. What is scalability? Scalability is nothing but depends upon the client data. We can take the n number of systems here. It's called the scalability here. For example, let's see from the client here I got some 100 GB. I got some 100 GB. So I'll take some 100 systems, for example. So suppose if you add the more data, then we can add the more systems here. Let's call the scalability we have. So it means we can take the single machine also, we can start the Hadoop. And we can simply add the number of nodes, depends upon your client flow of the data. And the cost effective wise, so see in a Hadoop we require the minimum hardware configuration, and it is an open source software, right? And coming to the flexibility, in a Hadoop, we discussed already, we can store any amount of the data and we can process the any variety of the data here. But see guys, these are all, they have a limit for storage, and the processing they have a limit, and the costly is so costly, software and hardware both. For example, next one is a fault tolerance. For example, let's see guys, I have one file loading into the one system. If system crashed, then what will happen? We lost the whole file, right? But see in Hadoop, see in HDFS, when you load your file into the one system, when see in Hadoop, when you load your file into the one system, the copy will go second system and the third system. Because in a Hadoop, we have a 3 times is a minimum replication we have, a recommended replication. Right? If any one system crash, not a problem. The same file available on the second and third. So depends upon the client requirement, we can decide the replication factor. It's called the fault tolerance. High performance. For example, let's say I have my job. My job is running on the first system. If my job failure, sorry, if my system crash, then the job will not fail. The job will be handled by second system. So it's a very high performance we have, high speed we have. So these are all the 5 characteristics we can say Hadoop is the best solution to handle the big data. Let's see now where we use the Hadoop. Suppose let's see guys, here I am the customer. I deposit the money in a bank. So what will happen here? We have backend as a DB, right? Database. So we have a number of customers doing a number of transactions with the bank. So what will happen? So this DB will update every time, right? This is called this is nothing but bring the OLTP, right? OLTP is nothing but this online transaction process. So processing the real-time data, processing the transactional data means real-time data. Just now it's happened. So see, this DB is a small DB which maintains only few month statements, right? Which maintains only few month statement. So where is your whole database? So we have a DB is everything on the back end as a big data warehouse. So what the banks they will do is for every 3 months, 6 months or 1 year, right? So they will upload all these DB into the backend as a big warehouse. So in this big warehouse, you can't do any manipulation. You can do storage and you can do analytics, but you can't do any manipulation because it is a OLAP. OLAP is nothing but, right, is an online analysis process. So online analysis process we have. So Hadoop is for OLAP. Hadoop is for handling the big data warehouses, storage and analysis we have. Right. So now let's start with the Hadoop framework. So we discussed Hadoop is a data management framework, right? So framework we have. So framework means we have so many components available. So see in Hadoop basically we have two are the core components we have. One is the HDFS and one is the mapreduce, right? From the client here, now we got the data, you can do the storage, right? You can process, right? So in a Hadoop also, so we can do the storing and processing here. HDFS, it is for storage. And let's see the mapreduce, it is for processing a data. First let's see HDFS. HDFS is nothing but it's a Hadoop distributed file system. See the name on the parallel processing, right? Distribute the file system. Parallel processing concept. For example, let's see from the client here, I got the 100 GB of the data, so I'm taking 100 systems here because we have a scalability and I'm doing the parallel processing. So let's see in HDFS, so I'm taking the more data, taking as a more systems here. In a Hadoop, right, in a HDFS, each system we call as a data node. For example, let's say my laptop is a one data node, right? See in my laptop, I have a, right, so see in my laptop here, I have a 1000 node, my laptop is a one data node. So here, if you see, I have a C, D, E, F for the hard disk drives, right? The same way in every node, we have a number of blocks available here. So guys, what is the Oracle block size? Any idea? Oracle block size? It's a 4 KB, right? So if you take the 100 MB file, how many blocks required here? 25,000 blocks, 25K blocks. Because the file in MB block size in 4K KB only. So, right, but see in a Hadoop, see in HDFS, 64 MB is the minimum default block size. The minimum default block size. So if you take the, right, if you take the 100 MB file, how many blocks required here? Maximum of 2 blocks, right? 2 blocks here. So what I am saying is that in a Hadoop, so right, the block size are very high here because we are handling the big data. 64 MB is the minimum block size, 120 MB is the recommended block size, and the 512 MB is the maximum block size. So this is a question for Hadoop certification. In a Hadoop certification, they'll ask, is a common question, the block size, right? Block size information. So like this, we have a number of blocks, right? Everything on the nodes, all the nodes in the racks, all the racks in the cluster level. So store the data, distribute the data across the different nodes in a cluster setup we have. Let's see the sample cluster. See, this is the cluster, these are all the racks, and these are all the nodes. In each node, we have internal logically, we have a number of blocks available here. So if you want, I'll show you a small video. So how the IBM cluster looks like. Let's see a small video. Let's say 2 minutes video, 2 seconds video. Just a few seconds.
Wind energy in today's world is important because the world is running out of fossil fuels at some point in time, and we have global heating as one of our current challenges. The 2020 target in Europe is that in 2020, 20% of all energy has to come from renewable energy. And a lot of those 20% is coming directly from wind. The only way we can maintain being in number one in modern energy is to stay ahead of our competitors using the latest technology. The most windy location may not be that location that generates the best revenue for the customer. So the sizing of turbine becomes a very complex discipline. Wind in itself is kind of a volatile source. It fluctuates and need to convince our customers that what we supply them is a reliable source of energy. And the only way you can prove reliability is by analyzing the data you have available. We have the libraries of wind ready. We estimate that we will be in the range of 18 to 20.
See, these are all the nodes. This is the rack. In the node, internal logical blocks available.
4 petabytes of data. That is equivalent to watching 70 years of high definition video.
And this is the cluster. So like this, you can store the data, you can distribute across all the nodes in the racks. This is about storage. From the client here, now we got the data, we are storing everything on the HDFS, means we are distributing across all the nodes, internal logical blocks we have. From the client here, now we got the requirements like jobs. So these jobs are handled by processing on the mapreduce in a Hadoop system, because the Hadoop will know only mapreduce for processing the data. For example, let's see, I know about Java. Let's write the Java coding part, and everything is going to the mapreduce processing on the Hadoop system. Right? For example, let's see, guys, I don't know about Java. Then how we can process? Let's go for the Hive. Hive is a warehouse, and they have their own language is called the Hive query language. It's same like a SQL here. Here, every query is going to the mapreduce processing on the Hadoop system. For example, let's say I don't know about Java, I don't know about the Hive also. Then how we can process? Let's go for the Pig. Pig is a scripting language. Here, every query is going to the mapreduce for processing on Hadoop system. So, if you see here, mapreduce, mapreduce, mapreduce. It is a backbone of the Hadoop for processing the data, right? And these are all the depends upon our knowledge. So Java or a Hive or a Pig. So for example, let's see a small requirement in Java. It will take the 3 to 4 hours minimum, the coding part. And the same job I can do with the Hive, the half an hour time maximum. Same job I can do with the 15 minutes time for the maximum, because the coding part is a very less in Hive and a Pig compared to Java here, right? So these are the different ways of the processing a data, different technologies we have. For example, let's see, my client is using Oracle database, Oracle or DB2, any database. So I want to migrate from the other database to Hadoop. Right? How we can do migration? So normally we use some ETL tools, right? But see, in a Hadoop itself, we got the one of the component is called as ETL tool. So this is called the scoop. Scoop is nothing but you can import the data from the any database to the Hadoop. The same way you can export from the Hadoop to the any other database also. Right? So scoop is like a ETL tool. It's like a data exchange tool. So easy to import and easy to export also. So guys, until now we discussed only the core components. In a Hadoop, we discussed about storage on HDFS, processing on the mapreduce, using a Java knowledge or the Hive or a Pig, and using a scoop, importing, exporting a data. So from the Apache, we got all these core components. So 70% of the Hadoop is dependent upon these core components. But working on the real-time industry, guys, so you have to know about the advanced concepts as well. Let's see the advanced concepts. One is the Impala. Right? One is the Flume, one is the Solar, one is the Hue, and the Wuji, HBase, and Zookeeper. Let's see on Impala. Impala is nothing but it is like a minimum of 20 times and maximum is 100 times. It is a faster than Hive. Impala is from the Cloudera team. It's a backend engine is called the distributed secure engine. It's good for retrieval data, only for retrieval. Suppose let's see, my client is a Apple. They want to know about the iPhone 5 tweets, right? So where the tweets in social media, right? I mean online, right? So for example, Facebook or Twitter like that. So using a Flume, you can stream the web data and the store into the HDFS. Storing into the Hadoop storage, streaming the data, and whatever you streaming, store everything into Solar, and we can do the keyword search, and we can customize the collection also. So these both are for streaming the web data, right? Streaming the web data here. So for example, let's see, my client requirement is he want to see the analysis part. So he want to see iPhone 5 is a positive or negative tweets. Is it good or bad? Right? So how we can stream the data? For example, let's say I'm taking Twitter here. So using a Flume, we can stream the web data, store everything in Solar. Anyway, it's a part of the HDFS and store everything onto the Hive or a Java or a Pig. We can do the analysis, right? And once you got the output, then store everything into the analysis. Right? Again, storing output data we have. So see here, this analysis is nothing but this analysis is called the sentiment analysis, social media analytics, nothing but checking about each tweet is a positive or negative. So this is a one real-time project. So I'll cover this project as well. This is called the social media analytics. See, we discussed so many components until now, right? So see name all the Hadoop components, everything is installed on the Linux machine. Linux machine here. So in the Linux machine, we have so many commands, right? If you want to make a folder also, you have to write the command. So we got the alternative way is called Hue. Hue is like a web UI, like a GUI. So it means in Hadoop, you can access the two ways. One way is through CLI, means command line interface, writing all the commands. Or one way is a Hue. Just using the mouse, you can play with that. Just using a mouse, you can do everything. And the Wuji nothing but schedule the job. HBase is nothing but processing the real-time data. See, we discussed Hadoop for OLAP, right? And Hadoop started the OLTP also using HBase. So actually until now, right, we discussed Hadoop is the best solution to handle the big data and doing as analytics. And they started with the real-time processing also. It means take the big data and we can manipulate also. We can change also data, right? So this is called the OLTP processing in here. HBase also processing the OLTP data. You see in the market. So until now, using the big data handling, storing and processing. And recently, right, all the companies started the OLTP also. They're mostly focusing on the HBase technology also. So here what I will do is I will show the different types of integrations like HDFS to HBase, like Hive to HBase, like Pig to HBase, like HBase Java API, HBase Java API to connect to the client machine. So I will show you all these ways. So these are all the not the theory part. These are all the real-time scenarios, real-time project level. So whatever I've worked in the real time, I'm just showing everything here. And coming to the Zookeeper is a coordinator between the multi-clusters and for to adding a node, removing a node. So we use Zookeeper tool here. See guys, these are all the basics, and these are all the advanced concepts. This is all about overall the Hadoop technology. So let's see from the client. Here we got the raw data. Okay, so we're using Hadoop for storing and processing the big data, right? End of the day, right? So client want to see the reports, right? If you see the output of the Hadoop, you will see the billions of records also. End of the day, client want to see the reports. So here what I am doing is, right, I will teach the Tableau reporting tool as well. So Tableau reporting tool as well. Tableau reporting is nothing but, so Tableau is one of the best reporting tool. Under the 500 Fortune companies in US market, Tableau is one of that. You will get the good quality of the reports here. So here what I will do is, I will take the data, I will use the Hadoop for storing the big data and analytics, and I will show live reports to the Tableau. Live reports means whenever you append a new data to the Hadoop, automatically my reports will change in Tableau. This is called the live connection. Got it, right? For example, let's see, until the last night I got sales report. Okay, I did the reports done, and now I got new data. Instead of doing the reports manually again, they simply append this data to the existing table. So automatically our reports will change in Tableau. This is what the client wants, right? End of the day, client wants reports only, right? So this is what the client wants here. And coming to the installation part, guys, so Cloudera is one of the best flavor here, right? Is a flavor we have. At the same time, I will show you about how we can make our own flavor, because in real time, suppose if you say, see the client, sometimes he will say, I don't want to use any flavor, let's make your own flavor, because Apache Hadoop is open source, right? Let's make our own flavor. Yes, you have to know about, right, how to install the manually Hadoop in the Linux machine. So nothing but I'm covering as the admin part here, and the development part here, and the BI tool called Tableau as a business intelligence tool. So covering as a whole, ending the project, whole end-to-end solution as a project level. So covering as end-to-end. So taking from the client raw data and give the client reports. In between, doing a storing, processing, analytics, and the making reports. So everything we have. So we'll use all these components we have. Okay. So coming to the materials point of view, guys, I have 14 GB of the materials in my Google Drive. I'll share the drive, so you can access any time this drive, right? And the same time, I'm doing the mostly online training, so I will record all these sessions, right? I will share these sessions. So because Hadoop is new, Hadoop is a new technology, right? So if whenever you want to see the record session, you can record. So these total topics will take around the 40 hours time, so max 1 month, because we can plan the weekends if you like it, then we can take the weekends also, right? So 40 hours it will take maximum, right, covering as all these advanced technology and everything we have. Coming to the practical point of view, right? See, my teaching is 99% of the full practical sessions. Every day you see the real time different types of scenarios, not theoretical. Right? Hadoop is a new technology. It's very interesting practically. Right? We have so many ways of processing data. So you have to practice a lot and a lot. So I will guide you on each topic. I prepared each topic for all the commands and the procedure, everything we have. So that you will find everything on my Google Drive, and some of the materials I will share through my mail also every day. And I'll share all the PPTs, whatever I show in the screen here. right? And from the Cloudera guys, I am the certified. So if you are interested in certification, I will get you for certification also. I prepared each topic on number of questions, right? So those will help for certification also. And so I will make the resume point of view also. I will send you some of the resumes, and I will change it according to your resume point of view, resumes also. So because it's new technology, right? So you have to put the keywords correct in the resume. Okay. So this is all about topics, guys, from the starting journey. So any doubts?